Well, you've been here for a week, so I'm sure you're a bit tired. That's how I feel when I go to the NBR, Summer Institute in Labor Economics, every summer, and by Thursday the last thing I want to do is hear another paper. So we'll do it a bit in a light way. One way of doing it this way is to allow you to interact with me as much as you feel you want. Ask questions, make comments, raise suggestions. The work that I will present today, probably 3 different papers, are still not published, so your comments might actually influence the quality of those papers. So please feel free to interrupt me anytime you want. I will talk, the first part of the presentation, we'll talk about discrimination. It might take actually the whole 3 hours because I want to present to you 2 new papers on that. One based on the behavior of teachers, discriminating in the classroom based on gender. And the second paper is discrimination of educators based on the religiosity of students. And I'd like to show you what we do in that paper and get your reaction to that as well. If I'll have time, I'll move to the second topic, which I was planning to talk about, which is market mechanisms in public education. That I was planning to talk about how to devise and produce a pay-for-performance for teachers and follow students from early childhood to adulthood and see the consequences of paying teachers based on their productivity. And the second part would have been looking at school choice at early childhood and following individuals to adulthood and see how that type of freedom affect individuals. So we'll start with the main topic of our morning, which is looking at the discriminatory behavior of educators. The first part will be teachers, the second one will be examiners in Israel. Okay, so there is a lot of recent work that look both in economics and in psychology on implicit biases of individuals that might lead to prejudice and discriminatory behavior. Implicit in the sense that it might not actually lead to explicit action of individuals. People may be aware of their biases and may actually avoid behaving based on those biases. But very often, individuals are not aware of their biases, their prejudice views about different groups in society, and they may act actually based on those implicit biases. So it leads to explicit discrimination across groups. In our case, teachers, they may not be aware that they may have preferences by gender, ethnicity, immigrants, other groups in society, and actually act based on those stereotypes and affect human capital outcomes of individuals. I will talk about papers where the explicit bias is done in primary school or in middle school or in high school, and it has consequences for individuals even where they are much older at adulthood, leading to effects in the labor market, on occupations, and on earnings. So what I do in some of my papers is measure biases of teachers in a certain way. The work started by Blank 1991 and Claudia Goldin and Rouse in 2000, and the idea was to use blind and not blind observations of individuals' performance. So, for example, Goldin and Rouse looked at, I'm sure you're familiar with that paper, Orchestrating Impartiality at the AR 2000, when they look at musicians who take tests at different orchestras in the US. Some of the orchestras use blind behind screen performance. Others test individuals, musicians, when they see the musician playing. And they look actually at the comparison in terms of offers made to female versus male musicians in both type of orchestras and offers in terms of wages. And in a convincing way, in a way, they find that female musicians are discriminated against in terms of offers that they receive by about 20%, and the wage offer that they receive is also lower by about 15%. So this is one of the first papers that really documented very clearly discriminatory behavior based on gender in the labor market. In a paper a few years later, I took that idea to the education sector. And I used it based on observing for every student a blind score, test scores in an exam, and a non-blind score. The non-blind scores usually are graded by the home class teacher, and the non-blind are usually taken from national testing exercise when the examiner or the grader is blind to the identity of the individual. He doesn't know his name, his school, his gender, his ethnicity, so totally blind, and he gives a grade based on what he sees in the exam. So in a paper in 2008, I used the high school matriculation baccalaureate program in Israel, where kids are tested in many, many subjects, on average 10 different subjects. 7 or 8 of the exams are done at the end of high school, June of your 12th grade. And in each exam, a student gets a score from a school level exam, where the class teacher is grading that exam, and a score in the national exam. The two tests are very similar in structure, in the material they cover, and the final score in the back of that subject is a weighted average, 50% and 50% of the two scores. So you have a blind score and a non-blind score. And I basically compared the two scores in many, many subjects, in all the subjects, actually almost over 20 subjects, and the outcome was very surprising, showing that on average, teachers bias upward the grades of female students relative to their external objective score in the national exam, relative to the same thing for male. In every subject, the 20 subjects, that was the finding. High school teachers have a bias in favor of female students when they are grading internal exams. Now that is open, of course, to different interpretations actually. Are we capturing really teachers' behavior, or is it something else driving the results? Which could be student level behavior, classroom level behavior, unobserved features of the environment that I'm not controlling for. And that was something that was addressed carefully in the paper. Yes, please.
Yeah, that was exactly what I was thinking about. So girls, they might feel less pressure if they just know that it's the teacher and not somebody they don't know.
Right. So there are many, many concerns that one can raise regarding this finding and the interpretation that it's really derived by the behavior of teachers. Okay. For example, one of the way I defended this counter interpretations is to see that the variation was highly correlated with characteristic of teachers. Okay? So the age of the teacher, his education, whether he's married, how many kids he has, whether he has only girls, only boys, what's the proportion by gender of his children. So there was many characteristics of the teachers, and if it was a behavior only of students, then it shouldn't be correlated with teachers' characteristics. But there are many ways we defend the interpretation we favor and we push in that paper. Following that paper, a list of about 20 papers were done and published replicating the same idea for countries in Europe: Norway, Sweden, Germany, the Netherlands, England, Brazil, Chile. Everywhere, people replicated the same idea about gender. In most cases, the findings were very similar, especially when done for high school, that in high school, teachers tend to favor girls. But the idea was taken to other directions using blind and non-blind evaluations to look at race discrimination, discrimination based on race of individuals, on ethnicity, against immigrants. Okay? So there's a whole list of papers. So that's the paper I just described to you, which I have done. Do gender stereotypes reduce girls' or boys' human capital outcomes? So that was based on Israeli data. And then there are those papers that I mentioned, and I want to highlight only 3 others of those. For example, Rema, Hanna, and Linden took that idea to a lab experiment in India, and they wanted to test whether there is discrimination based on the caste of the students. And they randomly assigned names of students that can be related to different castes, and they have tested based on this random assignment of names to teachers, and they found that teachers give a lower scores to lower caste by about 0.03, 0.08 of a standard deviation. That's not trivial. Okay? If you think about that, class size in a good environment would increase test scores by 0.15 of a standard deviation. When you reduce class size by a full standard deviation or more, this is not a trivial effect. Okay? And that can lead to inequality immediately, contemporaneously, and of course later in life. So that's one paper that have evidence that's consistent with statistical discrimination. This is a paper done in Brazil that look at bias assessment of teachers based on their ethnicity, and again, controlling for the blind score. All these papers either use the difference between the blind and non-blind as an outcome, which net out actually everything about the student that is fixed, so using sort of differences and differences, or actually control on the right-hand side for the blind score. So it's a more flexible specification. And in this paper, again, they have found that blacks get lower scores by teachers when their identity is revealed to the assessor. So there was another paper I wanted to show here. No. Okay. So I think we have now enough evidence that suggests that teachers discriminate in schools, in other environments. The question we want to pursue today is, what is the consequences of being exposed to a teacher who has a prejudice views about your group? What are the consequences in the short term? What are the consequences in the longer term? Okay? Does exposure to prejudice at early childhood, primary school, middle school, affect your preferences about field of studies later on at the university and college? Does it shape your choice of occupation? And of course, that will affect earnings and inequality in the market. So that's the main question. So in this paper, we took that question and addressed it with data from Israel. This is together with Edith Sand from the Bank of Israel. The title of the paper is The Origins of Gender Gaps in Human Capital, Short and Long-Term Consequences. So again, we exploit the blind and non-blind distinction of test scores. And I will show you in a minute. We measure a bias behavior measure for every teacher. Okay? We measure for every teacher his average bias behavior, and then we look how it affects students later on in life. So in this paper, we rely on random assignment of students to teachers. We have a blind and a non-blind scores. We aggregate the bias of a teacher in a given classroom, and we see in early childhood, let's say in 5th grade or 4th grade in primary school, and then we see how it affects cognitive performance of students in 8th grade and in 12th grade, 7 or 8 years after the initial shock or treatment, if you want, of exposing an individual to a certain measure of biasness. And we also look at later life outcomes. And what we find in this paper is that indeed, biased behavior of teachers in early schooling levels carry on consequences later on. So if you are in a class where your teacher in math is a pro-girl teacher, and you'll see in a minute what do I mean by pro-girl teacher, your outcomes 2-3 years later in different test scores will be better. Your choices of studying STEM subject in high school will improve. So the likelihood of a girl studying math, science, physics, or computer science in 11th and 12th grade will increase if she was exposed in 4th or 5th grade in primary school to a teacher who was a pro-girl teacher. And this measure varies by subject. So you can have a girl or a boy exposed in primary school to different teachers. You will see that there is a whole distribution of the prejudice measure across teachers. Some teachers are pro-boys, some teachers are pro-girls, even within a school, even within a class. So in this paper, we have a class fixed effect. So really, everything about the class, needless to say, the school, etc., is held constant. So whatever is specific and special about the class environment is controlled for, and we have measures that differ by different teachers who teach that class. So these findings suggest that prejudice impacts students in terms of their behavior and outcomes later in life. This paper was taken, the methodology, by Camille Terrier. She's French, she's a postdoc at MIT, and she applied the same idea to data from schools in Paris. So our paper was school in Tel Aviv. She took the same idea and implemented it for schools in Paris. And she found actually the same thing, using exactly the same methodology, blind and non-blind testing, looking at primary kids in schools in France and following them to high school, observing test scores later on, and observing their choices of field of studies in terms of math, physics, etc. in high school for the BAC program. And she has exactly the same set of results. Gender-biased grading accounts for 21, well, before that, male students make less progress than female students when they are exposed to a female-biased teacher. And the gender-biased grading accounts for 21% of boys failing behind girls in math during middle school. So we know, we'll talk about it more later, that girls are outperforming boys almost in every subject until the end of high school, even in math and physics. Partly because it's a very select group of girls who decide to study physics at a high level, while boys have a less selective sample in this comparison. But overall, girls are doing much better than boys, and in some countries it's even considered a national crisis. For example, in the UK, it is viewed, the gender gap in favor of girls is viewed as a national crisis, and a lot of resources are now devoted to close the gender gap. And ironically, it's to close the gender gap, so to push boys to be better. Okay? We usually talk about gender gap against girls in terms of the labor market, wages, earnings, etc. In this case, in Britain, it's the other way around. So that's the second paper that came out by Camille, yes?
So in terms of teachers, does it matter whether they are men or women?
This is an issue. In my case, in Camille's data, most of the teachers in primary schools almost all over the world are female. You will see in the main paper that I will present in a minute, where I have 30% of the teachers are male. And we took account of the potential differences in the biased behavior. Not much of a difference, although there is some difference. Okay? So this is a third paper by Michela Carlana. She graduated this year from Bocconi and got a job at the Kennedy School at Harvard. And this is her job market paper, okay, following the same idea. But instead of using test scores, blind and non-blind, to measure prejudice across teachers, she actually used a test developed by psychologists at Harvard, the IIT test, an implicit association test, where you can test, I'm sure you are familiar with it, on a screen in a computer, test and derive implicit biases, prejudice of individuals. Implicit, okay? If you're not familiar, you basically are shown pictures of individuals from two groups, could be black and white people, girls and boys. You expose the individual sitting in front of the computer to pairs of words that are opposite in nature, So stupid, smart, beautiful, ugly. And then you are shown pictures. You have to push a button and associate one of the two words with the picture that you see. And the outcome is based not so much on your choice of the words, but on terms of the time it takes you to push the button. Okay? And it was proven that it's very difficult to manipulate the results of this test. Okay? So Michela have done this for 300 teachers around Milan, in Milan and surrounding small towns, and use that as a measure of a biased behavior of teachers, and look how it affects test performance of students and choice of subject. Okay? And she found, again, that teachers who are pro-boys in terms of their prejudice affect positively boys and negatively girls, and the other way around. Okay. What's the problem with these three studies? Mine, 2015, Camille, 2017, Michela, 2018. Yes?
Is there any evidence that the IAT and the blind, non-blind measure basically correlate? So are they capturing the same thing? Because it could be, but...
Okay. Well, not in her paper, because she doesn't have blind and non-blind scores. I have a project with a professor of psychology in Tel Aviv University where we do exactly that. We first assemble teachers to grade exams where we assign the name, male or female, randomly, so we can compare the average bias of teachers when they grade female students' scripts versus male students' scripts. Then we give them some questionnaires to fill. Then we give them the IAT test, and I described last night at dinner. And then we ask them, how do you think you did in the IAT test? We explained to them that was the purpose of the test, exposed, and we asked them, how do you think you did on that test? So to your question, first of all, there is high correlation between the bias that we measure based on grading and the IIT score. And second, which is amazing, is that individuals are totally clueless about their IIT results. I mean, they might come out as really pro-girls, and they would have predicted something else altogether, or they said we are totally neutral, and then they actually come out to be prejudiced. So,
did you show them their results later?
Yes, we did. Yes, we did. Yeah, and the last leg of this project is to design an intervention that will help teachers get rid of their prejudice behavior, make them aware of it, and train them to behave more neutrally. So what's wrong with these three papers that I just described to you, to these two PhD students and my paper with Edith? Anyone has an idea? Yes?
I don't know, if you have tests for, you don't know what happens in the classroom, I don't know if you, well, the impact might be...
It's more basic than that, actually. The problem is, and this leaves ajar a very small door for an alternative interpretation, even though we do everything possible to show the interpretation we suggest is the one we want really nail, there is still an open possibility that it's not that. Why? Because all three papers measure the stereotypical behavior of teachers based on information of their current students on whom they study the impact of this measure. And in terms of Carlana, she makes the IIT test at the same time where the teacher is teaching a class at which she examined the effect on. Okay? So it's a contemporaneous measure that is done simultaneously with the exposure. So you might think that still there might be some feedback from students to teachers that we observe actually, and the causality might run in the other way. We do everything to show that that's not the case. But still, I think it would be really nice to measure the behavior of teachers over time and to examine how persistent. If you are a biased person, if you are a racist, are you a racist over time? If I measure your racist behavior year after year after year, how much inertia there is in that type of behavior? Okay? What's the correlation of T minus 10 and T-1 measures of behavior of teachers. Okay? So this is really a challenge because you need panel data on teachers. You need clear link between teachers and their students in class. So that's basically what I want to present to you. So this is a paper with Regisa Megalokonoumou. She was a student of mine in England, and now she has a job at University of Queensland in Australia. And that's exactly the objective of this paper. Measure the persistent behavior of teachers over time, in this case over 10 years. Measure their biases out of sample based on their previous behavior and see how they affect their current classroom. So there is no feedback possible from the current student to the measure we have. Okay? And then we take that idea to the data, and we follow students until the end of high school. And the main contribution, beyond identifying persistent behavior of prejudice of teachers, is to see how it affects their choices of field of study at the university. Okay? Whether you study math or biology or chemistry at the university, how was that affected by the exposure to different teachers in high school? So maybe I shouldn't spend much time in terms of the background. We already know that girls outperform boys in primary school and in high school, almost in every subject. There is still some gaps in favor of boys in terms of STEM subjects in some countries. But when you go to the labor market, there's a huge gap in terms of proportion of girls studying computer science, for example, proportion of girls who are engineers, and proportion of girls, for example, who are computer engineers. Out of the total computer engineers in the US, this data based on 3 years ago, only 10%, 1 of 10 computer engineers in the US is a female. Okay? So there is a gap. So you want to understand really what's behind this gap. And in our case, is it something related to the schooling environment, in particular to teachers and their biases? Okay? I'll skip all this discussion about the debate, what explained these gaps, the debate to date, focusing on biological and non-biological, environmental factors versus biological factors. There is whole literature on that. I'm sure you're familiar with some of that. I will only say that it's very difficult to disentangle the impact of biological gender dissimilarities from environmental conditions. There are several studies trying to do that in psychology, in science, in economics. Very difficult. One of the difficulties is it's very difficult to measure stereotypes or prejudice of individuals and link in a causal way those prejudice to individuals' outcome and behavior. Okay? So this is the objective of this paper. We measure high school teacher gender grading biases and examine first how persistent they are over time. At the individual level, different teachers by subjects. We have hundreds of teachers, thousands of teachers. Test whether the teacher biases during high school influence students' performance in high school and then in university admission exams, and then on their choice of university field of study. Okay? We use data from Greece from 2003 to 2011. We have panel data. We observe every teacher on average teaching 15 different classes. Okay? So it's very rich in terms of being able to see how persistent is the behavior of the teacher over the average of 15 different classes, which means different set of students in every class. So we measure out of sample, as I said, and this really relieves the concern that the measure of the gender bias may just pick up random, sometimes because of small sample variation in unobserved quality or non-cognitive skills of boys versus girls in a particular class. Okay, so that's the open jar, I said the open door, slightly open for different interpretation, even though all the papers, the 3 papers that have addressed the topic until now, have given that careful attention. It's not 100% safe. Okay, and that's what we do in this paper. So let me skip about discrimination. And I'll skip the result. I'll tell you about it later on. There are a lot of literature in psychology that explain how teachers implicitly can favor boys and girls in the classroom and enhance their cognitive performance. Starts simply for giving more attention, addressing more questions, challenging more boys or girls relative to the other group, encouraging, assigning more difficult assignments to a certain group. So there's a whole literature, and most of it is based on classroom observational data. There is like we are having the picture and the movie video taken here. Similar experiments done in psychology when a movie is taken of how a teacher is teaching and then analyzing it. And very often when a teacher sees in a video clip how he's actually behaving in class, he's astonished. Most teachers are not aware that they are either addressing only boys or only girls. They are challenging only boys or only girls, or challenging more boys relative to girls. Okay? Very often that's the response. They're astonished. Okay? So there is enough evidence that suggests that behavior in the classroom could be based on implicit prejudice. Okay? So this famous neuroscientist, David Amodio, who became very famous in recent years, analyzed this he coined this term unconscious bias. So the implicit bias, in his terminology, is an unconscious bias. He studies that practically more in the case of a racial prejudice of individuals, but also in terms of gender. And he documents, together with studies that follow him, that individuals really are unaware of their implicit biases and may go a long way in their behavior that reflect those harmful biases and effect on individuals. So this one we've seen. So we use data from Greece of 11 graders and 12 graders. We have 135 schools all over the country. We have data from the Ministry of Education in Greece and from school archives. The exams, the blind and non-blind, were done in 11 and 12th grade in most years, and in some years only in 12th grade. We went to 22 schools and got the teaching roster and the assignment of teacher to classes in those 22 schools over 11 years. So in subsample of the full sample of 135 schools, we have very detailed data about the assignment of teachers to different classrooms. So we can see which classes a teacher have been teaching in the past and who's teaching now. And we link all this data into a baseline sample that we use in this analysis. We use the fact for identification that students in Greece are assigned randomly to classes. They study in 3 different tracks: the classic track, the science track, and the exact science track. So there is a choice involved. So we'll do some of the analysis within track. But the assignment within a track and within a class to teachers is random. And we actually show in the paper that the integrity of randomness is held with the data. Any balancing test you do of individual observable characteristic and their outcome are unrelated to their class composition. So these are the schools from the different islands and places in Greece. We actually traveled to every school that you see on the map here. To 135 schools. I myself went to the 22 schools, each one of them, which are a subsample. And you can see that it's a random sample, though underrepresentative of schools who are in rural areas. So we have more schools in urban areas in the 22 samples. So there are 3 tracks. All students study core subjects: modern Greek, history, physics, algebra, and geometry. The 3 tracks are, as I mentioned, classic science and exact science. You start your track in 11th grade. The classics have emphasis on ancient Greek, philosophy, and Latin. Science include mathematics, physics, and chemistry. And the exact science include these 3 plus computer science and no chemistry. Okay? The same thing in 12th grade. There is a bit of a change in 12th grade relative to 11th grade. So this is some descriptive statistics from the 135 schools. This is in 11th grade. About 56% are female. Okay. We have that information on absenteeism. Here is the distribution by track. 37% study in the classic track, 28% in the science, and 34% in the exact science. This is in 11th grade. In 12th grade is very similar. There's a small attrition between grades in terms of the tracks. These are descriptive statistics about university enrollment. Let me see here. Okay, about 50% of the high school students enroll in the university in an exact science department, 4% in science department, humanities is 19%, and social science is 22%. 20% enroll in vocational schooling. So we will study how the biases in high school affect the choices of enrollment in one of these schools. A few words about education in high schools in Greece. It's a very centralized system administered by the Ministry of Education. All universities are public and are free. Admission is based on national exams done at the end of high school. We will test how the bias of your teachers in high school affect your performance in these university admission exams. Students apply to universities. They can list, I think, up to 20 universities at 20 different fields of study. And they are admitted based on cutoffs of every university and every department and based on their average score in this national exam. You can be denied your first, second, third choice, and you are admitted in your fifth choice, etc. So that's the process in terms of admission to universities. Okay, so now we move to the national exam and the school exams. Boys, girls, the difference between the two in core subjects and in the tracks. Here is classics. The next slide is on the other two tracks. And you can see that the difference between the average score of boys and girls is almost always negative. When it's negative, it's large. That means that in the national exams, girls outperform boys in the national exams. All the scores are standardized z-scores, so in terms of standard deviation. What you see here, for example, in physics, boys have an advantage of about 6% of a standard deviation. So they do better in physics taught as a core subject. The same thing in geometry. But the gaps are relatively small relative to the gaps where girls are better than boys. Okay? This is the school exam on the same subject, done about a week to 2 weeks before the national exam. And you see huge gaps, much bigger than here, in favor of girls in most cases. This is a half standard deviation advantage of girls in modern Greek relative to boys in the non-blind score, the school score. And you see that in all cases, the gap is in favor of girls. Okay? The same thing in classics. Here are in science and in mathematics. Okay? This should be negative. No, that's plus actually, that's okay. So in most cases, you see that there is a gap in favor of girls, both in the external exam and in the school exam. Yes?
Do they know the result from the school exam when they take the national exam?
No, not yet, because it's done between a week to 2 weeks before the exam. That's the same thing in our sample of 21 schools. The same picture emerge. Okay? So we take this data. Yes, please.
Are there any incentives for the school teachers to manipulate the results?
Incentives in terms of salaries and stuff?
Yeah, or that they're assessed based on the average number of placements at the top 5 universities or something like that. When they should
No, but though if there is such an incentive, and there is a paper by Petra Persson from Stanford now looking at grade manipulation, test scores manipulation in Sweden, that shouldn't be, well, at least there's no reason it should be different for boys and girls if the origin of the behavior is incentives. Okay, and she shows in that paper that there is school inflation in terms of school grades relative to national exams, and it's the same for boys and girls. Okay, In our context, there is no incentive built in for teachers to manipulate test scores, although all teachers have their school exam scores higher than the national. It's the same thing in Israel. Yes?
And do they have incentives to actually be not too far away from the national exams? So are they compared?
I'm sorry, I don't...
If the gap is too big, do they get kind of a penalty?
No, it's nice that you raised that. In Israel, we have that.
Yeah,
Okay?
well.
And I use that actually in a paper to show that, if I'll be able to show that paper, that pay for performance doesn't lead to a behavior where teachers actually are giving higher grades based on the. In Israel, you are punished actually. The school is punished.
Yeah.
Okay? But not in Greece. Yes?
And do teachers know the cutoffs? So could they manipulate, students' test scores so that just make it across the cutoff?
The cutoff is sort of a moving target depending on test scores of individuals in the same year that is applied. I wouldn't rule out the possibility that teachers, when they grade school exams, would really like to increase test scores of their students so that they will have a better chance in being admitted. But again, that should not be a differential by the gender of the student. Okay, so what do? We measure the average bias in a classroom. So we take the difference between the national exam score of every student and the school exam, so non-blind, blind, and we average for all male students in a given class. Then we take the same thing for girls, and we average it for girls. And then we take the difference of the two. So it's the average gap by gender for a given teacher in a given classroom. Okay? And we get basically a measure which we standardize as a zero mean and a unit standard deviation. Okay? So we do it for every teacher, for every class that we observe him teaching in his teaching career within the window of data that we have from 2003 to 2011. As I said, we observe teachers on average teaching 15 different classes. So we will have this measure of the teacher gender bias on average 15 times. So if we look at data in 2000 and in 2011, we will have data from 2003. There's a question of whether you use lead means that you see. So say you look at the teachers and his behavior in 2004, do you use his mean bias in 2005, 6, 7 later on? Okay, that's an interesting twist in how you can use the data. So we repeat this procedure for every class, subject, and grade. Positive values indicate bias in favor of boys. Negative values indicate a bias in favor of girls. Okay, and we construct this average. We observe high variation in teacher discriminatory behavior. So I want to show you the graphs. Well, before that, first I'll show you the tables. So this is the bias in 11th grade, the proportion of teachers who are female, okay? The mean bias of a teacher in his current class at time t. This is the mean bias of a teacher in all other classes except the class at time t. And this is the correlation of the two biases. Okay, so that's one way of seeing how persistent is the bias over time. So the current bias, contemporaneous, for example, in modern Greek, has a correlation coefficient of 0.6 with the average bias of that teacher in all the previous classes or all the other classes that I've seen. So all the correlations are relatively high. All of them are significantly different from 0. Around 0.5, 0.6, we have even 0.67. Okay? That was for 11th grade. Here it is for 12th grade. Okay? So this is a regression of the current year bias against the mean bias in the past. And you see that the coefficient here is 0.8 when we include subject, year, and school fixed effect. And the coefficient is the same 0.813 when we drop the school fixed effect. It's very, very high, almost close to 1, highly, highly significant. This is based on over 800 teachers. This is in 12th grade. Okay, the coefficients are a bit lower. So we see high correlation, high inertia in the bias that we measure for teachers. If you are biased 10 years ago, you are biased 5 years later, you are biased 10 years later in a given subject. We do, yes?
Do teachers become more or less biased over time? Do you know that?
Yeah, well, I'll say something about it in a minute. But here is a nice way we can twist the data to shed light on these questions of inertia and persistent behavior. We have some subject that is taught in the classroom with the same teacher. For example, the same teacher teaches math and geometry. The same teacher will teach history and ancient Greek. Okay? But there are cases where those two subjects are taught by two different teachers. How can we exploit that data? So we look at the correlation of the bias when it's the same teacher teaching that classroom versus two different teachers teaching that classroom. If it's indeed teacher's behavior, the correlation when it's the same teacher should be very high, and when it's two different teachers, it should be very low, close to zero. In that case, we know it's not something about the students or the class or the school, it's really something about the teacher. So you see here, when we aggregate over all subjects, that when it's the same teacher, the correlation between the two biases in the two different subjects is over 0.7. And when it's two different teachers, it's 0. Okay? Now, we have here examples. That's in 12th grade. In these figures, for different subjects, we show the distribution of the blind, of the bias in the current class, and the average bias in all previous classes. So the green is your current class, the distribution, and the white, the bars when we add the white, are the distribution of your average bias in all other classes. So here is an example in 11th grade, and you see that there is a big overlap. And you see why we have a high correlation between the two measures, the one with your current class and the one with previous classes. This is the data. This is the raw data. Okay? So this is the bias in your class today, and this is the bias in your average class in all previous years. Okay? And you see the positive correlation, relatively small deviations. This is in classic. The other one was in core subject. This is in classic. You see the data. This is in science subject. You see the data. This is in the exact sciences, and you see the data. So in every field of study, in any subject, there is a high correlation, high persistent behavior of teachers over time in how we measure their prejudice behavior. And this is when we group all classes together, all subjects together, the coefficients become even more precisely estimated. Okay, so we document practically that there is high persistency in the biased behavior of teachers. What do we do with it? Okay, so I think this is a major result in the paper, which we couldn't do in our earlier work, nor the other papers that are following the same question and the same approach. And so we take that and we want to see whether the bias of a teacher, this is the teacher bias, measured out of sample, is affecting outcomes of students. So it's outcomes of student I in a school or class C in subject J and year T. Okay? So in this linear regression, we control for student characteristic. In particular, we control for the score in the national exam. So we really hold constant his ability. Okay? Hold constant his ability together with some other characteristics like his ethnicity, etc. We have a high school or a class fixed effect, okay, within this framework. So really, the most demanding specification, we have a class fixed effect. So we have different teachers teaching that class different subjects, measure their bias in the past, and see how variation in that bias is affecting contemporaneous current test scores of the student within the class. Anything about the class is controlled for. So if the school principal is very, very good, if there are some unobserved characteristics of the environment, if parents are highly motivated, if they're highly educated, anything that is constant for the class over time is controlled for. And we have this measure of ability by subject specific. Okay, so we really take care of variation in the human capital innate endowment of students. So that's the teacher bias, and we have a class random term and a student idiosyncratic random term. And as I said, for identification, we rely on the random assignment of teachers and students to classes in high schools in Greece. And we show that it's indeed supported by the data. Okay? There's two issues econometrically that you should be aware that should be accounted for in this exercise. One, some students have a teacher for which we have data on his previous bias based on 300 students. Some teachers or some students we have a bias based on 200 students. So there is sample variation that might lead to measurement error in comparing different biases of different teachers. So we use Bayes estimates to account for this sampling variation. Second, we basically generate a regressor. We estimate the bias of a teacher and put it on the right-hand side. So we use two-step bootstrapping method to compute standard errors when we estimate the result. So this is sort of demanding in terms of computer time, but are necessary in order to get consistent estimates of the parameter of interest. So we use different specifications, and I'll show you a result based on different specification. Okay? So first, let's look at teacher gender biases and test scores. So we look at boys and girls separately. We look at their grades in 12th grade, and we measure exposure to a bias of their teacher in 11th grade. So how are you doing in math in 12th grade given the bias of your teacher in math in 11th grade and across all subjects? So we pull all subjects in the core topics, classic subject, science subject, and exact, and we do it separately. So if you're interested in the empirical setup, we stack the data for every student in the different subjects in each of these sub fields, so core, classic, science, and exact. We stack all the subjects. For each subject, we have a specific bias of a teacher, and we estimate it separately for boys and girls using 3 different specifications. But for the sake of time, let's look at column 3 here and column 6 here. This is the effect of boys, and this is the effect on girls. Estimation is done separately. Every coefficient comes from a separate regression. What you see here is that a 1 standard deviation in the biased behavior of a teacher leads to 0.2 test score gains if it's a pro-boy bias for boys, and negative 0.085 for girls. So if you have a pro-boy teacher, the effect is symmetrical but with opposite signs. It affects positively boys and negatively girls in the same class, in the core subject. In the classics, it affects positively boys, the coefficient here is very large, and negatively girls, less precisely estimated. In science, 0.12, 0.14, opposite signs. Okay? So you get this symmetry, which is amazing. And for exact science, again, positive effect on boys, negative effect on girls. Yes?
Informative of,
I can't hear you, I'm sorry.
Is the symmetry informative of the type of discrimination?
Wait, it's too far.
Is the symmetry informative of the type of discrimination? So what I'm thinking of is you could either have, say, I believe boys are just, worse off and I need to help them, right? They deserve more help. So this would be some kind of positive discrimination. I could also say, I just don't like girls, right? So really, I want to give them a hard time.
Okay.
So, you know what I'm saying? Is the symmetry maybe informative about the intention of the teacher, even if it's not deliberate, even if it's subconscious, but there may be some motivation behind it, right? And the
Yeah.
motivation could be very different. And
Right.
if so, it could play out very differently, depending on the either just helping one group or only putting down another or.
Right. Okay. So this is a very deep question here. Are you lowering the score of girls, or are you raising the score of boys? Okay.
Yeah.
Since it's a relative measure, we cannot tell in this paper. Okay, we cannot tell. It's a relative measure. In the paper I will present in a minute about religiosity, we use bunching in the test scores, and we are able to say, I think it's the first paper that is able to say who discriminate, the religious people or the secular people, the religious teacher or the secular teacher, who discriminate actually, and whether he is increasing the test scores of his group, so there is a love in-group bias behavior, or out-group hate behavior, lowering of the other. In this paper at the moment, we haven't addressed it. We might actually, now that we have this idea about bunching, we might go back and do something about it as well, and shed some light on this important question. Yes?
Do you think those facts are driven because I happen to have the same teacher in grade 11 and 12, and there's just this relationship that maybe is not ideal? Or is it more that I dislike the subject, and no matter if they have the same teacher or not?
We do look in that, actually. In many cases, it's different teachers, and the results are not very different when you split the sample and keep only those students where it's the same teacher. But remember, the bias is not measured on your classroom, it's measured on the teachers, and we actually do all kind of robustness checks. So we say, the measures of the bias of the teacher in classes he taught up to 2 years ago. Okay, so taking it away from your current period. Okay, okay, so we do document here, and these results are very similar in spirit and nature to what we found in our 2015 paper, what Carlana found in her 2018 paper, and what Camille found in her 2017 paper. Okay, that pro boys, and I didn't emphasize that in the distribution that I showed you, you saw that within a subject there are pro girls teachers and pro boys teachers. The average might be in favor of girls, but there is a whole distribution, and we need that distribution, we need that variation to do the estimation precisely. So it's not that all men or that all teachers are pro boys or pro girls. It's that there is a whole distribution. And I think one of the next steps in this line of research is to explain why some teachers are pro boys and some teachers are pro girls. What in their background, what in their environment where they grew up, etc., can explain that variation. We don't do that in this paper. Yes?
Could the symmetry also come from grading on a scale? So if you grade on a scale, then automatically if you bump some, you have to lower some others. So you kind of get automatically this symmetry.
Well, the mean across subject is very, very different. And the mass at the bottom and at the top are very, very different. So it's not that they are grading on a scale. Okay, so that's based on a sample of 21 schools, and looking at the effect in test scores in 12th grade. Now, you may ask me, okay, if the measures are based on the behavior of teachers in previous years, why don't you use that to explain variation in test scores in 11th grade, right? So we do that, and the results are very, very similar, okay? So we look at 11th grade test scores and look at the same measures of biases of teachers, and we get the same results, okay? Okay, so now we want to explain, we want to see whether this biased behavior in high school affect three things. One, whether you continue into any post-secondary schooling. Two, which field of studies you choose. Humanities, social science, exact sciences, sciences. And we also look at what's the likelihood that you choose a field of study at the university that is directly related to your track in high school. So what's the likelihood that if you were in science, in the science track, that you would study science at the university as a function of the bias of your science teachers across the different tracks? So I showed you already some evidence about enrollment in universities. You see the proportion of boys and the proportion of boys and of girls enrolled by this exact science, social science, humanities. Girls, on average, 33% of those who continue into university, about a third, study humanities, versus only 10% of boys. Social science, it's very similar, 28%, 26%. Science is the same. It includes biology, chemistry. So it's dominated, chemistry is dominated by boys and biology is dominated by girls. So they offset each other and the means are very similar. And this is exact science, which is mathematics, physics, computer science. 27% of boys study those fields versus only 12% of girls. Okay? Here are the differences, and they're highly significant. So can we say something about these differences? Are these differences related to the bias measures that we estimate? So that's first a regression of a logit or a probit regression of the biases in 11th grade by biases in core subject, classics, on the likelihood that you continue schooling at any department at the university. The results here are positive for boys, negative for girls, not always significant. So for example, if we look here, what's the likelihood that you will continue in a university field of study, any field of study, as a function of the biases of your science teachers in high school? It increased that likelihood by 2% for boys and lowered that likelihood by 2.5% of girls. So again, we see here the symmetry in terms of opposite signs and not very different subject. Okay, so then we move to model the choice. And we do a very simple exercise since we have a lot of observation. We estimate linear probability regressions. We stack the data for every student for the 4 choices possible for different fields of study at the university: humanities, social science, sciences, and exact sciences. You get 1 on that variable for the field of study that you actually realize and study, 0 otherwise. So every individual has 4 rows in the data, and we have on the right-hand side the bias measure for every field of study. Okay, so I don't have much time. I want to still continue with the second one in this session. So that's the effect on boys, and that's the effect on girls. And you can see already that the stars are on the signs of girls. And the effects on boys is practically either have the wrong sign and imprecise or precisely 0. It looks like the biases in high school, which affected test scores of boys and girls, in terms of choices and preferences, affect mostly girls and much less, if at all, boys. So boys are not movable in terms of their preferences, whether they want to study math or physics or humanities, given the bias that they were exposed to. And girls are affected, okay, are affected. That can explain actually why we might see more boys studying physics and computer science and why less girls are studying those fields, okay? So the choices of girls are sensitive to those biases, okay? And we can give explanations how that effect is generated in terms of motivation, in terms of self-confidence, in terms of self-image, etc. We don't have time to elaborate. We talk about it in the paper. Finally, we look at the effect of how the bias in a given field affect your likelihood of choosing to study at the university in that field. And here the picture is somewhat reversed. We see that boys are highly sensitive to that bias. So if you have a teacher who is very pro-girls in your math courses in high school, that will affect your likelihood of studying math at the university. Okay? It will not affect the likelihood of studying any subjects at the university in the exact sciences in general, but math will be reduced. So your math teacher will have a direct negative effect on the likelihood that you will study math. And then you might study physics, or you might study something else. Okay? So here, the results are a bit different for boys and girls. We do another exercise, which I will not elaborate, I'll just say, and I will stop discussing this paper. And that goes back to the inequality topic of this conference, of this summer school. What are the consequences of long term, okay, for students? So, of course, the field of study, etc., are very important. But here we measure something in addition, because if you are, admission to universities is based on thresholds and your average score. If the biases reduce your average score, you may miss the threshold. You may be just below or just above, okay? That may lead to allocative inefficiencies and to inequality. It will assign people to medical school based on an outcome where someone else should have been there, but because of the bias is just missing the threshold. So we look at what's the effect of the biases on the quality of a department that you study in university. So we rank all departments either based on the threshold or based on the average score of the individuals that were admitted in a given year. And we see how the biases affect the quality of department and university at which you are admitted for. And we find effects that you can see in the paper that are significant and symmetric, positive for boys, negative for girls. So it does make a difference. Okay, so even small changes due to this discriminatory behavior may make a big important difference for individuals. I have a paper that look at the effect of pollution on your brain contemporaneously on cognitive performance in a test. Okay? So we show in the paper that variation in pollution, in bad air in a given day at the time of the exam will lower your performance in the exam in high school. And then we show that it affects you, your earnings and your occupation at age 35. 17 years later, exposure to bad pollution at age 18 has an effect. Even though the effect might be small, even though the effect is nonlinear and really very bad days will screw up your human capital performance, it does carry on until a very late date in your life. The same thing here. Very small differences might determine whether you get to University of Athens or you have to go to University of somewhere else. Okay? And that may make a big difference in terms of your career path later on. So this is about this paper. It's the first paper that look at this persistent behavior of teachers in terms of prejudice and discrimination. And the results are very much similar to the papers that have not addressed this issue. Yes?
Can you basically do some kind of back on the envelope calculation to get at, okay, how much is basically the reverse causality, which is a problem in the other papers because they don't have these lagged measures of failure? I mean, in principle, you could like re-estimate everything you've done with the contemporaneous measures and basically just compare the effect.
Oh, we do that. That's a beautiful question. We do that. Actually, we have tables in the paper where instead of using your lagged previous measures of prejudice, we use the contemporaneous one.
And that's similar.
It's the same.
So basically,
because the correlation is 0.7, 0.8.
Yeah. So the reverse causality is basically not an issue in the other papers.
Right. Well, look, we have a class fixed effect here. It has to be something idiosyncratic about a given student, but the measure is the average for the class. And I look at differences across teachers within the same class. So I'm not surprised that I'm getting the same result. And the same thing was in the previous paper. We have a class fixed effect. Yes.
And the second question is, if you look at these different, if you look at these bias measures over time, and if you correlate them with classroom characteristics in a given year, can you...
Which characteristic?
Classroom characteristics of the class that the teacher has given. Can you basically look at how does the classroom composition basically affects the bias that I have towards males and females? I mean, basically, this would. if
It's
you're
not.
set-
Those are the balancing tests that we do. Right? So the bias, I mean, your current, say I look at time t class characteristic, the proportion of female in the classroom. Okay? That's
No, I mean, like looking at the bias from one year to another, basically how your bias evolves.
right.
Not,
Okay.
not whether the average correlates with characters. That
Yeah.
shouldn't be the case
Right.
because you want to have like a balanced setup. But whether like the measure next year and the measure this year, basically how they correlate and how this correlation varies with classroom characteristics. Because that would basically tell you how basically those biases evolve over time over the course of a
But they're not measured with classroom characteristic. That's the point. They're not measured with any characteristics. The most basic characteristic that might be important is what is the proportion of girls in the classroom, or what's the proportion of high ability girls in the classroom, or boys if you want, okay? There is no correlation between those measures and the bias of teachers in previous classes, and even with the current class. Okay? We can talk about it at the break. Yes?
I didn't have one to ask this, but I have a question more generally just with how you're interpreting the bias. And could it be that this reflects teachers rewarding non-cognitive skills or just non-disruptive behavior or effort? So if we were talking about this in the United States, I would think that, well, on average, boys in U.S. classrooms, like young boys are more disruptive. It's generally more disruptive, and some teachers may be more or less rewarding girls for not doing that, or non-rewarding boys, not rewarding boys for that. Is that what it is, or is it something else?
No, it's not. It's not. It's not violent behavior of boys.
No, and I
It's
don't
not
think it's
disruptive
not
behavior of
necessarily
boys in the classroom. It's not characteristic of students because, that teacher have been teaching different classes over time. It's totally, and there might be variation. There is variation in the proportion of boys and that thing. It's not. It has nothing to do with the students. It has nothing to do with any unobserved features of the specific classroom. Okay.
Maybe that's
Okay, so let me move on. I'll start and then I will continue after the break to talk about same type of phenomena: prejudice, implicit in-group bias, discrimination in education system. And this is joint work with Edith Sand and with Moshe Shayo, who is a colleague in Jerusalem, and Edith from the Bank of Israel. Okay. Okay. So same motivation as the previous paper. More an emerging interest in discrimination and prejudice behavior. I mean, these two papers I like very much if you are into the topic. Charles and Gurian, 2011 JPE, and they have also an AR paper. And Marianne Bertrand and Esther Duflo wrote a survey on discrimination and prejudice, and it's really a very nice piece of summary of where we are in this area. So anyone who would like to read more and move into this area should start with Bertrand and Duflo 2017. Most of the papers on discrimination related to implicit biases and prejudice have focused on either racial, ethnic, or gender-based discrimination. Okay? At the same time, there is a literature on religion, the effect of religiosity. But most of this literature is how being a religious person or the level of religiosity affect you individually and your outcome. Are religious people doing better in school? Are they doing better in the labor market? Are they doing better within a marriage? Okay? So there's a set of studies, and I Barrow and McCleary has an early paper, 2003. Bob Barrow from Harvard, he's interested in religious issue for a long time. There are some other papers. We don't have any papers that look at potential discrimination based on religious. Okay? Even though it might have important implications for human capital accumulation, as I will show you in this paper. One of the reasons that we don't observe many studies about discrimination and religiosity is that it's very hard to observe that variable, whether a person is religious or not, how religious he is. That's not a variable that is collected in administrative data. It's not a question asked in census in different countries. Very few surveys will include a question about your religious practices, but in those surveys cannot be linked to anything else. Okay? So part of the reason is that we don't observe studies about discrimination based on religion is that that variable is not available. Okay? It's not available. What we do in this paper, we propose a method of inferring religiosity based on very meaningful choice. Which school your children is attending. So you will see that in Israel, the schooling system, the public schooling system, has several segments that are totally orthogonal to each other in terms of the relationship. There's the Jewish secular, the Jewish religious, the Jewish ultra-Orthodox religious system, and there is the Arab school system. Okay? Every religious person, every kid from a religious family will go to a religious school. Every secular kid from a secular family will go to a secular school. And I'll say about it in a minute more. So we look at parents, and we infer the parents' religiosity based on the type of school that the children are going to. We can do that through administrative data. Then we implement the idea of checking discrimination based on religiosity by looking at professionals who mark exams, who mark the external matriculation exams in Israel at the end of high school, the one that I was describing to you. Okay? And there are certain features that will allow us to exploit that in a natural experiment to identify properly discrimination. So we look at grading decisions of those examiners. The system is central so that all students are taking those exams. And what's important, again, in terms of a chance outcome, is that it may determine long-term outcome. Because the Bagrut scores, I said, are crucial in being admitted to higher education, to highly demanded department. It's a medical school, school of engineers, and computer science, etc. And that basically determines your occupation later on in life to a large extent. So what we do in this paper, we will focus only on the Jewish population, leaving aside the Arab population for reasons I will explain in a minute, and also the ultra-Orthodox segment of the education system in Israel, because they don't take the matriculation exams. They basically study Orthodox biblical subjects, and they don't take secular subjects at all. So there are 6 important features in this context that allow us to do what we do in this paper. The first one I mentioned is that the system is divided into secular and religious schools. From that, we know the religiosity of the parents. And since we link the examiners to their children, we can observe where the children go to school. We can observe the religiosity of the examiner, whether he's a religious Jew or a secular Jew. Okay? So through administrative data and this feature of total segregation of religious family and secular families in terms of the school system, we are able to identify precisely whether you are a religious person or a secular person, both as a parent, as a child, and as an examiner. The second feature is that each exam in every subject is graded by 2 examiners. Okay? Assignment of examiners to scripts is random by a computer mechanism. So you as a student doing an exam in physics may get 1 secular examiner and 1 religious examiner, 2 secular examiners, or 2 religious examiners. That assignment to treatment, in a way, is totally random. So we can compare how religious examiner grade script of a religious student relative to the grading of the same script by the secular examiner. Okay? So now you ask me how, those are blind tests. I said in the paper before, there is no way an examiner can see from the paper note who is the student. No name, no school ID, nothing. How does the examiner can conclude whether he's grading an exam of a religious student or a secular student? So here, there was a question here. Yes?
Yeah, I was just wondering if the quality of the schools is the same. So is a religious school and a secular school are they?
On average, they are very much the same. Outcomes, I'll show you. But that's the point now. How do they know? So in Judaism, a religious person, when he takes this piece of paper, okay, you wrote something here, okay? The first thing he will do, he will write on the right-hand side 3 letters, BSD in Hebrew. Every piece of paper, a letter to your parents, a letter to your wife, a notebook when you take notes in a classroom, an exam, every time you start writing something on a piece of paper. If you are a religious person, you will have this Aramaic phrase, okay, which is BSD, which means with the help of heaven. All is determined by God, okay? That's something that all religious people do, okay? So I'll show you 2 pages from 2 different exams. This is a secular, this is a math exams in the matriculation program, 2 pages, question number 3, okay? You see nothing is written on the top here. That's a secular student. Now we know, as a econometrician, we know the school the student is coming from, okay? So we know he's secular, but the examiner doesn't know, okay? He can conclude from here immediately that that's a secular student. If he gets this, you see the note here, okay? That's question number 2, page 5 and 6 from a notebook of a religious student. He immediately realized this is a religious student studying in a religious school. Okay? There's another features in the system where you get a bunch of scripts from a classroom. So basically, the examiner has also the responsibility of detecting cheating. So he gets a map of the classroom where the scripts he's grading, where the students were sitting, with the exact sitting of every student, so that he can compare. If something suspicious comes to his mind, he can look where suppose he sees 2 exams that are very much similar, he can see whether they were sitting next to each other, and that can start an investigation. Okay? So even if a student doesn't write BSD, if 12 out of 15 in his set of exams that he's marking are BSD, he knows that the other are also from religious school. So we actually verified this by getting a sample from the Ministry of Education of notebook like that, and we found out that high majority of religious students write BSD on every page, and almost 0 of the secular students, actually 0, write BSD. Okay? So this actually closed the way we identify who's religious among the teachers, who's among the examiners, who among the students, and we know that they know about it. Okay? then there is another thing that we exploit in this analysis. I think we should take a break. I'll just finish this slide. All the studies about in-group bias in behavioral economics and discrimination, if it's not based on a lab and you use observational data, cannot tell who discriminates. But in this case, we want to know whether religious examiners have an in-group bias toward their group, whether the secular examiners have an in-group bias towards their group. But the only thing we can do with the standard method is to observe a relative measure of discrimination without being able to tell whether it's the religious person or the secular person who originated the discrimination. We also cannot tell whether the discriminatory behavior is by, we covered that point before, increasing the test scores of someone from your group or lowering the test scores from someone from the other group. That's where we use this feature that we have in the data, bunching. We have a full distribution from 0 to 100. And you will see that there is a mass of much higher proportion at 55, which is the passing threshold, and 100, which is the perfect score. Huge bunching. You cannot miss it, okay? Means that examiners are bumping up students from a failing score of 53 or 54 to 55, and they are also bumping up students from 98 and 99 to the perfect score 100. Everybody is doing it. Male examiners, religious secular, female examiners or secular. The question is whether they're doing it differentially when they are marking an exam of someone from the other group. So we'll deal with that after the break. Yeah.
How do you know that the bunching at 100 is really bunching or just a ceiling effect because the ceiling?
Exactly. That's a fantastic point. There might be truncation, right? That's the highest score. The only answer I have is that if there is an issue, it should be differential by religious and non-religious students in terms of the implication. And I will show you that there is a lot of discrimination based on religiosity, and all of it comes from male examiners, and female examiners are totally neutral. So the bunching should be really, really specific with its implication for male examiners and for the religious examiners, who are the one who do most of the bias. We finished the last session by talking about this feature of bunching, which will give us a lot of mileage in identifying who's biasing, who's really discriminating, and also whether it's increasing the test scores of your own group or lowering the test scores of the other group. And this is an example of students, religious students and secular students, religious examiners, and you see the full test score distribution, and you see bunching here at 55, this is the point, and the perfect score 100. And what you see is a hole here at 54 and a big hole at 99, okay? The same thing here for secular students. You see bunching here with a hole here, and you see bunching at 100 with a big, big reduction in the mass, in the density here at 99. So this is for religious examiners, secular and religious students. Eyeballing the data, you would not tell whether the religious examiner is doing it more for religious students versus secular students, right? But that's what we want to find out. He's definitely doing the upgrading, the bumping up of test scores for both types of students. The question is whether he's doing it more for one group versus the other. And this is for the secular examiners, again, religious students and secular students. You see very similar pattern in terms of the peaks at the threshold of passing and this threshold of perfect score. And by looking at the data, you wouldn't be able to tell whether the secular examiner is favoring more in this behavior his own group students versus the students from the other group. So basically, we are able to take advantage of this in a neat way. I will explain later that getting 99, I mean, it could be that religious students are different from secular students in terms of how they write their exams, okay? And it could be that an exam script of a secular student is of a higher quality than a religious script. But getting 100 versus 99 is probably independent of your religiosity status. This is just a random event. And that would allow us basically to look separately for an estimation with religious examiners and separately for secular examiners and estimate the bias in upgrading students from the other group. Okay, so so I go back to the features that we have. We were here. The last thing that we have here is that we have, I already mentioned that, we have the internal score for every student on every subject, which is reflecting his ability, okay? Might be biased upward because the teacher is aware of who you are, but it's a good measure of your ability, and we can control for that as well, okay? So that will allow us to rule out any spurious correlation between the grader and the student religiosity on the one hand, and student performance and given in a specific subject on the other hand, his ability. So that's another feature that is nice. Okay, so we've seen that. I told you how we identify religiosity, and then how do we identify discrimination in marking exams based on religiosity. We exploit the random assignment of scripts to examiners in a difference in differences framework. Okay? We have a natural experiment when assignment is random of students and examiners. So we examine the difference in mean grades given to religious versus secular students by religious and secular examiners, controlling for student and subject questionnaire fixed effect. Okay? So the most demanding specification, which we like, we have a questionnaire fixed effect and a student fixed effect, and we look within a student, and we see in cases where he has examiners of different religion status, how his score is affected. Okay? So we have to account for the status of the examiner as a religious examiners, because religious examiners might be more strict or less strict in general. Then we have to control for the student religiosity. Religious students can be better on average or worse on average, so we have a dummy for them as well. Okay? And then we exploit the threshold, as I said. So I will go directly. Okay, so there is a literature on discrimination to which we contribute in this paper. So the first one is the one I mentioned before, which is discrimination based on race and gender. And I mentioned the paper by Charles and Gurian and the survey by Esther and Marianne. Not much work on discrimination by religiosity. There is the discrimination papers of teachers grading biases, which I mentioned also before. Here are different papers. I told you about the paper by Hanna and Linden, by myself and Sand, and some other papers. Okay, so that's one literature. There is an effect. There is studies on the effect of religiosity on individuals' outcome that I mentioned as well. There is a large literature in sociology and psychology about in-group biases. Okay, and this goes back many years ago. Not all this work is careful in terms of identification. And there is papers on contact theory, which came from psychology and sociology, where people talk about the degree of discrimination or in-group bias based on exposure to the other group. So if you are religious, are you discriminating in favor of religious people as a function of how much you are exposed to secular people. Okay? So we are able to contribute to this by doing the following. From the administrative data, I know the home address of every examiner. From the student data, I know each student, whether he's from a religious family or secular family, and I know his home address, the student home address. So I can identify within a zip code, each zip code in the country, the proportion of students or proportion of families who are religious families. And I assign to every examiner that proportion as a treatment or as an exposure measure given his zip code address. So some examiners live in totally segregated religious communities, so they're not exposed at home in the environment to secular people. Some live in mixed communities where there's both, okay? And that will vary. So that's one measure of exposure, of a contact with the other group, so we can test the contact theory in a home environment. Another thing we can do, and I was asked about it in the break, secular teachers do not teach in religious schools. Religious schools are not allowing secular teachers to teach in their schools because religious schools keep certain religious rituals. They pray 2 times a day in the school. They eat only kosher food. They have a certain dressing code, and the boys have something on their hat, a hat or something to cover, okay? So religious schools keep those rituals, and they cannot have a secular teacher coming and a male or a female and not following the same behavioral and dressing code in the school. But the other way around does exist, so that you have religious teachers teaching in secular schools. So they are exposed to secular people through their work. So we measure for every examiner who teach, we know where they teach from the administrative data. We measure in the school where they teach, if it's a secular school, how many of the teachers are religious, and how many of their gender and are religious, and how many who teach the same subject that they teach and are from their group. So we have 3 different measures of exposure in the school, the widest, which is the whole school, all teachers, by gender and by the subject. And we'll show you that indeed, the more you are exposed at home or at work to people from the other group, the less prejudiced you are, and the smaller is your in-group bias towards your group. So you become more neutral, you behave like someone from the other group, but you don't discriminate against your own group, but you don't discriminate against the other group as well, okay? So in a way, this contact theory is interesting, and we are able to add some information within this context. And right. Okay, so the data that we have is administrative data. It's all placed in a lab, a government lab, where all identity of individuals, examiners, etc., is all protected. And we cannot identify individuals, but we're able to work with different sources of data, and we put them together. It's a virtual lab, so I work in labs where, like the previous paper, I have to go to the lab, the Central Bureau of Statistics. This one, you have a server, and you can connect to it from a distance from your office and work, but everything is disguised in terms of identity of individuals. So we have all the information about students, about their matriculation scores, their demographic characteristic. We know everything about the examiners, about their age, their gender, their education, which school they work, where they live, and we can follow them over time. They have a national ID, so we can link them over time. And we merge all this administrative data into a data set that we exploit. Okay. So the proportion of boys, some descriptive statistics. So the proportion of boys in religious schools is 38%, and in secular schools it's almost 50%. Why there are fewer boys in religious schools? It's not that the gender mix is lower. It's not that there are more boys among religious families, more girls among religious families. It's the sum of the religious families send their kids to ultra-Orthodox schools. And they basically send their boys. Okay? So there is another segment of the public education system, which are the ultra-Orthodox, those that you see with black uniform and with long hair and all of that. They don't study secular subjects at all. They don't take the matriculation exams. And some of the religious families in Israel send their boys to those type of schools. And that's why we have a less than 50% representation of the boys in religious schools. Mother, father's education is more or less the same, about 12 and a half, 13 years of schooling. Average family size, larger families among the religious families, over 2 kids per family. Among secular is less than 1 child per family. And then there is distribution of ethnicity.
Does that make sense? Because they have a child.
It's number of siblings.
Yes, number of siblings.
Oh,
That's
okay. So
not
it's-
including you.
Yeah, I was going to say there's at least one.
Right. So this is the average external score in the external matriculation exams, the BAC. So you see that the mean for religious students and secular students is the same. The mean, okay, unconditional mean is the same. So any t-test for balancing here would reject that they are different. That's the average in terms of the internal grade, a little bit higher for religious students. That's the final grade, which is the average of the two. The probability of passing an exam is the same, 89%. Right, this is by parental education, higher parental education, lower parental education, not much of a difference. And you see that we have over 2 million scripts for data that we analyzed from 2010 to 2015. Okay, so that's the data that we analyzed. The examiners, so number of scripts by all examiners. So we have here 2,700,000 scripts by female and about 500,000 by male examiners. So there are much more female examiners than male examiners, okay? And you see them in the secular and religious schools, and that's for the female. Each examiner is marking, on average, 2 different questionnaires. So to be an examiner, you have to be a high school teacher, and you have to teach. In the same year you are working as an examiner, which is the summer, you had to teach in the previous year that just ended a class towards taking the matriculation exams that you are marking as an examiner. So if it is a honor level math, which is 5 credit unit, the highest, you must have taught math in the previous year for that course exactly an honor level class. If it's an intermediate, 4 credits, or basic math, 3 credits, you must have taught that. Okay? So every examiner is a teacher, and he taught at that year exactly the topic or the course of the exams that he's marking. So teachers might, on average, mark more than 1 exam, more than 1 questionnaire, because they might teach 2 different levels of math, basic and advanced, etc.
So to a certain extent, they're by marking maybe higher the student in their group, they're maybe benefiting themselves because they will be their students. So suppose I'm a religious teacher, I teach in a religious school, and then I see a religious group, I might be marking my...
No, you never mark your own school. That's not allowed.
Okay.
I mean, first of all, it's done randomly.
Yeah, no,
But-
it's
but-
randomly, I know, but...
Yeah, no, but the random
Excludes your school.
exactly.
Okay.
You cannot mark your own school scripts.
So
Yes.
it's not actually random. Well, it takes out your students.
Yeah,
Then
it's living eye in a way.
So it's 0% probability that you will teach. Okay.
Your own.
Okay.
Yeah. So you mark on average almost 1,700 scripts. Okay. number of scripts per school. So you get on average 12 per school. So you can divide this by this and you can find out how many schools, different schools you mark. The students are taking, okay, this is something I should mention. The religious schools curriculum include some subjects where the exams are specific. So it's like in Talmudic, which is like old scriptures, studies. The secular segment of the education system do not study that subject. So the matriculation exam will be only for religious students and not for. So there should be an overlap. We take only the subjects where there is a full overlap. So on average, in the end of 12th grade, there's about 5 exams like that per student. That's the total number of scripts that we have. That's the total number of schools. Okay, so there's more information I can skip that we've seen. Okay, so again, summary statistics, proportion of male, female, religious, secular, male, female. I'll skip all of that. Some characteristic of the examiner's age and ethnicity, identification strategy I discussed. This is balancing that shows that the random assignment of examiners to scripts or scripts to examiners indeed is random. There are, for all examiners, for male examiners, for female examiners, and there is only one correlation which is significant here out of the 30 or so estimates that we have here. So really a random process. Okay, so what do? We estimate the effect on an outcome, a student test scores, script S, by student I, assigned to examiner J in questionnaire Q at year T. So we have 5 or 6 years of data, and we have T years in the data. So we have a dummy for a religious student, a dummy for a religious examiner, and then the interaction of the two. And that's the parameter of, that's the parameter of interest, alpha 3. That's what I want to identify. And then we have a student fixed effect, a questionnaire fixed effect, and times fixed effect, and a random term in this regression. Okay? So we show 3, 4, 5 specification. The first one, the baseline one, has only a questionnaire and a year fixed effect. And then we add an individual fixed effect. Then we add a specification with interaction. And then we have a script-specific fixed effect, okay? Which is the most demanding one. But we will favor the one that has a questionnaire fixed effect and an individual student fixed effect. Okay?
Sorry, one question. Maybe I'm a bit slow, but how can you identify the coefficient on the religious student dummy? Because you have an individual fixed effect in there.
So when I have an individual fixed effect, that drops. And you can see it here. Okay? That's first specification, a religious dummy, a secular, a religious examiner dummy. So you see that on average, religious students without student fixed effect have a lower score. Even though the unconditional was the same, when I condition on some characteristic, you see that there are 5 percentage points of a standard deviation lower test scores. Religious examiners on average have a higher score given to students, regardless if they are religious or secular, 2 percentage points of a standard deviation, and that's the interaction. Then we add a student fixed effect, this drop. Then we add an examiner fixed effect, and this one drops as well. And then we have a script fixed effect. And what do you see here? Let's focus on this, that the in-group bias is positive, small, and not very precisely measured, though it has a T of about 1.6, about 1.7. So it's small, 1% of a standard deviation. Okay? We split that to boys and girls, to male and female examiners, and you see that the male examiner, the bias is 0.03 of a standard deviation, 3 times the mean I saw before. And for women, it's much smaller and not precisely estimated. Okay? So this is a pattern that will replicate itself throughout the study. Male examiners discriminate. Female examiners are blind to the religiosity of the student. Okay? So next, you want to know whether something else is accounting for this bias. So there are many characteristics of the students. In particular, we have the gender of the students, whether he comes from a high education or low education family, his ethnicity, different ethnicities, or all of them together. So what we do, we add a control for each of these characteristics, without the student fixed effect, of course, and we allow for the main effect of each characteristic, and we allow for the interaction of the student characteristic and religious examiner. Okay? So this is the bias, and you see that it doesn't move regardless of which control we add to the regression. It's 0.01 throughout. And actually, when we add everything, it's 0.012. So it's even bigger and more precisely estimated. And what's nice is that the main effect of all these characteristics are 0. So there is no omitted variable bias in a way, because these are 0. Okay? All of them. But even when we add all of them, you see that the coefficient here is 0.012. So we're not worried about the fact that it could be, suppose that the examiner can tell from the test whether the student is a Russian immigrant. And that teacher has a soft spot for Russian immigrants. Okay? And the likelihood of Russian immigrants being secular is highly, highly likely. Almost 100%. So what we see is not a religious bias. It is a pro-Russian immigrants bias. Okay? So that's sort of a favoritism to something else that characterizes the students and not religiosity. Well, that's not the case. Okay? You see that it's not the case in any of the things. Another thing that you can think about is a sort of a coincidence of taste in terms of writing styles or motivation and explanation style. So the examiner is favoring the way the student is writing the exam. Okay? Well, what we do for that is that there is no style in doing a math exam, right? You solve problems. So we divide all the exams to STEM test scores and non-STEM test scores. And you see that you get more or less the same coefficient. Okay? The same coefficient in STEM and non-STEM. If anything, it's larger for non-STEM. Okay? So it's really also not a coincidence of taste, of reasoning, of explanations, etc. Yes?
So in this setup, you understand religiousness as a binary outcome, right? You are the religious or not. Do you think that this difference between male and female examiners is because male religious teachers are more religious than female religious teachers?
That's an excellent question. I'll tell you what I think about it, what we think about it. I don't think that female and male from religious families are different in terms of religiosity. At least I cannot tell. But I can tell you that in Judaism, the saliency of religious practicing is much more salient for male than for female. So a Jew who is religious will have to go and pray 3 times a day, in the morning, before sundown, and after sundown. He will have to pray in the morning. I don't know if you're familiar with it, but he has to put on his hand something that takes like 5 minutes to put on yourself, from leather strips that are black, that he puts on his hand all the way here and on his head here. And it takes him 5 minutes to put it before he starts praying. Okay? Many of them go to religious classes in the evening in the synagogue, once or twice a week. So there are many, many things that would make religiosity more evident on your daily life than for male than for female. Now, if I tell that to religious people, they won't like it, okay? They won't like it. So my answer for those who do not like it and think that it's not the case is that there are other studies who show that women are less prejudiced than men in other ground. For example, there is a paper by Uri Gnizi and Chaim Freshman at the QG 2000, I think, or 2001, when they used dictator games on a lab to detect discrimination based on ethnicity between Sephardic Jews and Ashkenazi Jews. So between European Jews and the Middle Eastern Jews. Okay? And they randomly assign names that are revealing whether you are a European-style Jew or Middle Eastern-style Jew. And they find a lot of discrimination against Middle Eastern Jews. Those were students at the university. When they do it by gender, all of it came from male students and 0 from female students. So female students were less prejudiced. And there was dictator game and a trust game when you have to transfer to the other player. And you saw that everybody transferred less money to Jews from Middle Eastern origin. Even male students from Middle Eastern origins trusted less their own group students, okay? But not among female. There's other studies in psychology that suggest, lab experiments, that suggest that women are sort of more neutral and less prejudiced in their behavior. I think about racism as well. Yes, please.
Have you used I guess the examiners do that like several years, and you could like incorporate that into your...
I use what? I'm sorry?
The examiners grade exams, well, they have to teach the previous year, but you couldn't see...
Yeah, we have an exam specification with an examiner fixed effect.
Ah, okay. Yeah.
We do have that.
Oh,
If you look at it, yes.
So could it be that there is selection into the women who teach in the religious school? So it might be that the very religious women, they stay home, so they would not be a teacher. So
Yeah, that's beautiful. I think this is really a nice point. Is that who are the religious teachers? Is the selection of male and female teachers along the same lines into the teaching profession? What do you think?
So I could imagine that very religious women, they would not be working, but I don't know like how common it is in Israel that the women would stay
Okay.
home.
No, so in Judaism, women do work. Actually, the absurd is that even in the ultra-Orthodox families, female labor force participation is 75%, and the male labor force participation is 25%.
Okay.
So it's the women really who support the men who actually sit in seminaries and study until age 50 biblical issues and stuff like that.
So I have another question.
So it's not an issue of working, not working, but it could be that the male who select themselves into the teaching profession are different than the female who select. And it could be that if the teaching profession is not a very lucrative position, male who become teachers may find themselves a bit disappointed. So it could be. But you will see that most of it comes from religious male examiners and not secular male examiners, at least part of the effect. So it has to be something specific about religious men. Could be.
So
I would expect religious men, because in religious schools there are more female teachers than male teachers. And now in Judaism, mixing male and female is a sensitive issue. Like for example, now we have in the Israeli army women doing almost all the jobs, even in tanks, fighting unit, pilots, women are into that as well. And there is an issue what to do with the male religious soldiers. If you are you don't want to be in a tank where there are 4 people in a tank and one of them is a woman. So there's an issue. So it could be that the male who select themselves into a working job where the majority are women is different. I don't know what to say about that.
could you also measure, like make a more continuous measure of the examiner's
religiosity by like the number of children they have in ultra-Orthodox schools? Like, or at least an indicator whether they have at least one child in a more religious school?
Yeah, that's something. Well, there are nuances in the religious school system. There are some schools who are more strict. For example, we can measure that, and we tried. Some religious schools have total segregation by gender in classes. You work on that. Okay, so totally male classes, female classes in high school. But most of the religious schools most will have segregation, some will have mix. So we wanted to see whether you teach in a school where there is a mix, so that school is sort of less religious. We didn't get much on that.
You said that you determined the religiosity of the examiner by looking at the children, whether they are depending on their school. So you drop the examiners that don't have.
We observe for the young examiners who are not married or do not have yet children, we don't know. We don't know their religiosity, except that we see where they teach. But as I said, some religious teachers teach in secular schools. But if we assume that they teach we assign them a religious status based on the school that they teach, and we don't drop those, then we get similar results. But you're right.
Yeah.
We are able to identify, I think 91% of the examiners have children in school.
Oh, 95, okay.
Yeah.
Yeah, because
91.
I was thinking that maybe the non-religious examiners would be maybe older.
Yeah,
the religious
there was a characteristic of that. They're not very different. Okay, so we do it by subject, like in math. When you would expect that there'd be less room for discrimination if it's a math script. Okay, and you see that in literature and math they are really the same. Okay, in English they are the same. Okay, so really not much of a difference. Even in math, you can discriminate and you can give a lower score. Okay, then we look at some average outcomes of passing an exam. What's the probability of passing an exam? Because that can affect the likelihood of getting a matriculation diploma, and we get some nice effects. Okay, so I want to say something here. And okay, so now we look at bunching. That I showed you these pictures before. So we divide the range from 50 to 60, and we select a sample of only scores that fall within these ranges, and we do it for male and female examiners separately. So we want to see whether the likelihood of moving a student from any score within this range to above 55 or above, is correlated with this interaction of religious students and religious examiner. So the outcome is 0, 1. Did you get a score above 54? You get 1, 0 otherwise. And we do it with samples that varies by the scripts that fall into these ranges. Okay? And you see that this is for male examiners and this is for female examiners. For male examiners, that likelihood is 3 to 4% higher if the student is from your own group. Okay? So you bump up a student from 54 to 55 by 4 percentage point higher chance if he is one of your group. And for women, it's again 0. So we found on average almost a 0 effect, 0 discrimination for women examiners. And within this bunching at the margin of passing, it's also 0. We do the same thing for the test scores close to 100. So we go from 90 to 100, then 98 to 100, 99 to 100. Again, the outcome is whether you get 100. Equal 1, 0 otherwise. Male, female. Look at this beauty. Female, again, are totally neutral. Even though we saw bunching for women. It's not that they don't upgrade students, but that they don't do it differentially based on the religiosity of the student. And you see here for male, look at the huge effect. The likelihood of taking a student and giving him 100 instead of 99, if he is from your own group, is higher by 10 percentage points. Okay? And it's higher also from 98 to 100. And it's also higher from 95 to 100 in the whole range, 95, 6, 7, 8, 9. This is meaningful because there are some fields of study in the university. You want to get to medical school, you really need top scores. You need 100, I think, in all your matriculation exams to secure a place in a medical school in Israel. Otherwise, you will study in Latvia or Bulgaria or Romania or Italy. Okay? So this upgrading could be very meaningful for some students, and the effect is not it's not trivial. It's large, and for women it's 0. Okay. So now the question is, who is the villain in this story? Who is really discriminating? We know it's a man, okay, but we don't know whether he's religious or secular or both of them. Okay, so okay, that's the 0. We don't. Who discriminates? Okay, so here we rely on this. Yes.
Actually, I forget. They're discriminating in favor of who, right? So in favor of religious students?
Is it a religious teacher discriminating? And we have a relative measure right now. Okay.
No. I mean, so for what students? I forget which students are getting the bump. It's the religious students.
No. Both.
The same group.
Both are getting an upgrade in their score. Okay. Both by male and female examiners. That's we know. Okay. It's the question is whether the relative upgrade that we get when there is a match between the religiosity of the examiner and of the student, is it coming from the secular pair or the religious pair? That's what we want to know.
And also, I mean, they see the writing, right? We know that we can tell, like, female writing versus male writing, and I know you can't, like...
That's our next paper.
That's your next... Really? Okay, but you can tell.
No, it's an interesting issue to know, and that's in psychology and behavioral economics, an important question. If you have a paper that discriminates in one dimension, let's say gender, would you also be a racist? Would you also be against immigrants? Okay, now very topical issue in Europe, okay? So if you are a prejudiced person on one dimension, are you prejudiced on other dimensions as well? So that's where we want to combine the gender, if he can identify the gender by writing.
Oh, you can.
No, not always. Not always. In this study that we did, that I do in Tel Aviv with the psychologists, we gave examiners certain scripts and we asked them to identify the gender of the student. Not very successful.
That'd be good.
Not very successful. So that's we have sort of a controversy between us, the co-authors, whether to pursue the gender thing or not. Maybe in literature and history and those subjects it's easier than in math.
Yeah, I know when I'm grading my students, I can.
Yeah, you know. Okay. And you know now that everybody is using typewriters and I mean, the handwriting I think deteriorated for everybody, including women. Okay. It's not, you know, you remember the days where handwriting was so nice, it was like a picture.
I don't remember.
Yeah, well, I remember. Not anymore. Okay, so we rely on this randomness of getting 99 versus 100 and 54 versus 55. That should not be correlated with your religious status. Okay, so we look first. Okay, that's another thing that we do. That's another thing that we do. Okay. Okay, so now we divide the examiners by, yes?
Sorry, so when you show the histograms, there was also this bunch at 0.
Right.
Why don't you take that into consideration?
There is some tables on that.
Okay,
and
you want to focus on the 100.
Yeah, but there isn't much going on in terms of discrimination. The 0, some of them are missing test scores that are assigned 0, and I don't know that that they really have zeros. Yeah. Okay, so here we divide the sample to secular examiners, religious examiners, and we run the thing separately. So it's not really diffs and diffs anymore, okay? But it's not diffs and diffs because I focus on ranges where it's random whether you are in one or the other. And again, it's nice to see for female examiners, regardless if they are secular or religious, it's 0. So women, regardless of their religious status, are sort of neutral with respect to religiosity. And the male, it's different. You see the coefficient on religious examiner is positive, not so precisely estimated in general. Here it's significant, 0.027. So this means that the chance that you will bump up a student from 54 to 55 or 57 for religious examiner is higher by 2.4% if the student is also religious. And for secular, it's in this case close to 0. Okay? Given the standard error, you cannot tell that the minus 0.007 is different than the positive 0.024. This even have the wrong sign. Okay? It should have been positive. No, that's against religious students. It should be negative. Okay? Now pay attention now that this should be negative for in-group bias and this should be positive for in-group bias because that's a religious status dummy. So it's a bit of a mush in terms of the evidence, even though we already get a hint that it comes from religious examiners. Okay? And now we move to here, to the upper part of the distribution. And again, you see 0 for women, regardless of if they are religious or not. And this is the amazing result. If you are a religious examiner marking a religious student's script, you will upgrade his score from 99 to 100 by 10% higher likelihood relative to if the student was secular. And for the secular examiners, it's only 0.017, and it's not precisely different from 0. So the average 0.09 that I saw before when I combined in the diffs and diffs secular and religious examiner was coming all from the religious examiners. So at the thresholds, either of passing or of perfect score, clearly the evidence for the criminal in this case is the religious examiner. So you want to know whether the average that we found of about 0.03 for the whole range, is it coming all of it from religious examiners or secular examiners has something in the other ranges of the distribution. So we re-estimated our model the beginning, dropping the range of scores from 90 to 100 and from 50 to 60, and focusing only on the other part of the distribution. And we do find some evidence of discrimination. So the discrimination doesn't come only from those two thresholds, it comes from other parts of the distribution. And for other parts of the distribution, we cannot tell whether it's the religious examiner or the secular examiner. Okay? Only at these thresholds of bunching, we can say something about that. Okay, so back to the question whether you lower the score of the other group, or whether you upgrade the score of your own person from your group. The fact that we find spikes in 100 and a hole in 99 and a spike at 55 and a hole in 54 is suggestive evidence that you really improve the outcome of someone from your group, but not at the expense of absolute decline in the score of someone from the other group. The outcome is a relative measure of bias, of course, but it's done by improving the scores of your own group and not harming the one from the other group. Okay, that's the final thing I will say, and I will stop on this topic. We found that women are neutral. Okay, so they will become our Swiss referee. So their score is the objective score of the exam. Let's go back to diffs and diffs when we pair a secular male examiner with a female religious examiner, or a female secular examiner, doesn't matter, and a religious male examiner with a female examiner, secular or religious, and do a diffs and diffs at the threshold. And that's what we do here. And amazingly, you get exactly the same results. The diffs and diffs for the pairing of female secular and religious male examiners give us exactly 0.01, okay, 0.1, exactly what we got before. And for male, exactly the same number. So our assumption that getting 99 or 100 is orthogonal to the status of religiosity of the student is a good assumption. We see that when we move back to do a diffs and diffs, we get exactly the same result. Okay? So it's sort of a nice, reassuring exercise. Okay, I'll just tell you that the in-group bias is declining with exposure. As I mentioned, there's a lot of results here, and I'll end up with that. Any question about this?
So you are doing the male-female? You are.
Well, we just had a meeting the day before I left on Wednesday, because there's two things we can do. We can combine our method of the Greek and Israeli paper on measuring the bias based on blind and unblind score. Okay. And since every examiner is a teacher, I have his blind and unblind score in high school when he is teaching towards the exam, and then merge that with the religious exercise we do here. That's a cleaner exercise because I don't have to rely on identifying girls by their handwriting. So what we decided is to go for it first based on assuming that he knows based on handwriting, and do it for STEM and non-STEM subjects and see what we get, and then see if it's worth investing all the effort in doing it. Yeah. Okay. So let me move now, for the time that we have left, to talk about something else. It's very important in economics of education. Why? Everywhere in Europe, America, developing countries, people are looking for ways to improve outcomes in the education system. There's hardly a country where they are happy with their education system. Maybe Finland until 5 years ago. But even Finland now is unhappy with their performance of their students. Especially where education system is based on public funding, it's public schooling, and there are no incentives built in schools to perform up to the production frontier of students and schools. So we know from several studies until now that teachers are an important input in education, and that better teachers lead to better outcomes. How do we know that? So Hanushek has a paper with Steve Rifkin, Econometrica, 2005, measuring teachers' fixed effect in a way similar to what people have done with firms and workers. And they found the teacher fixed effect are very important. Going back 10 years later, what's his name? Chetty. Chetty and co-authors have measured teacher effectiveness by looking at value added of schools in New York, primary schools, measured value added let's say properly, although there is some criticism about it, but measured value added properly that really reflect the input of teachers. And they find that teachers' value added has long-term outcomes on earnings of students until age 27. They find no evidence that teachers' value added in primary school has an effect on high school test scores. So the effect fade away at the beginning, no effect of test scores in high school, and then re-emerge in high school, in adulthood by age 27. They show huge effect on earnings. Okay, so we know that. What is it about teachers that make a difference? Hanushek has a fixed effect, which is a black box. I don't know what it is. Chetty and co-authors call it value added. What makes teacher have higher value added? If I'm a policymaker and I want to improve the school system in New York, and I read Chetty's paper, I'm very happy if I'm from the teachers union, but what button should I push to increase value added? That's not known. It's a black box. Hanushek for years have shown that teachers' quality is unrelated, or student characteristic, student outcome are unrelated to any measure of teachers' characteristic, either experience or age or level of education or even your performance in college or in high school, SATs, your average grades in the university are sort of not correlated with your performance as a teacher. So we really don't know much about how to improve teachers' value added. So in this project, I have several papers that try to penetrate this black box. So I have a paper with Joshua Angrist where we first try in an experiment on-the-job training. Anyone who is a labor economist is familiar with this concept, general training and on-the-job training. And there we designed an intervention where teachers were treated in the school every week on Sunday. Sunday is the first day of the week in Israel. We work on that day. Every Sunday, expert teachers will come to school and will teach teachers how to teach the material that they are supposed to teach on that week. And we've done this paper, I think, in 2000. The intervention was in 1994, 1997. And we found large positive effect of treatment on the treated, okay, relative to the counterfactual produced by the experimental control group. So we know it worked on test scores. Now we are looking at those kids who are now 33, 34 years old, and we're finding evidence that the test scores gains carried on into college attainment and into the labor market with higher earnings. Okay? So that's one element in a black box, improving on-the-job training to teachers. Okay? Not many other studies exist in this area. So what I want to talk about today is an experiment that I did in year 2000, 2001, where I introduced a market mechanism into the remuneration of teachers, into the pay the teachers get for their work. And the pay was based in this experiment on the performance of their students. Okay? And I'll tell you exactly how it was done. And that thing was, I wrote a paper about it, a short-term effect, came out the AER in 2009. Now, I'm looking at them at age almost 35. And I want to see whether paying for teachers based on performance in high school leads students 15, 20 years later to earn more and to get more college degrees as a result of the original intervention. Okay? So this is what I want to talk about in the remaining half an hour that I have. So the intervention identified about 100 schools that are weak performance on average in math and English. and designed a pay-for-performance scheme for the teachers in math and English. I could not randomize the experiment, so I designed a threshold where all schools below this mean, countrywide mean matriculation rate, which was 45%, will get into the program. All of them above it will be out of the program. Now, since the average matriculation rate for religious schools and Arab schools was a bit lower, 43, I used two thresholds. 55 for secular schools, 43 for Arabs and religious schools. Okay? So all teachers teaching English and mathematics entered the experiment. All the teachers were teaching in advanced matriculation exams towards the exams at the end of the year. And the program was designed as a tournament, like a tennis tournament. You basically compete against teachers in your field, and you can win a prize if you are ranked high in the tournament at the end of the tournament. You enter the tournament with as many classes that you teach toward the matriculation exam. So it's like tennis tournament. If you play singles, doubles, same sex, double, mixed sex, you can enter the tournament 3 times, right? Wimbledon now played, people are playing the singles, doubles with a female partner, doubles with a male partner. So you can win 3 prizes in the Wimbledon. The same thing here. So it's a rank order tournament. It's based on a paper by Sherwin Rosen and Ed Lazear from the University of Chicago, a very, very famous paper, JP 1982, when they designed this rank order tournament and show how useful it is for designing pay-for-performance schemes. So this paper is structured around Sherwin and Ed's paper on this topic. So you enter the tournament, and I can determine based on some predictions whether you've done better than I would have predicted for you, and you get prizes. So you get first prize, second prize, third prize, fourth prize. You gain points based on the average score of your class and on the passing rate of your class. Why? Because the Minister of Education wanted to not only to improve outcomes for the average student, also to increase the passing rate in the exams. So you gain points. If you are in the first place, you get 16 points based on the average score and 20 points based on the passing rate. You see that you get more points on the passing rate. The policymaker, the social planner, wanted to put more weight on passing the exam than improving the average score. And then you get total points, and based on your total points, you are ranked. And if you are in the first place, you get $7,500 prize added to your salary. Second place, based on number of points, you get a bit less. And 9 points, you get just below $2,000. Those are meaningful prizes. So in terms of design of mechanism design of experiments like that, what you should take from this is that the prizes are not trivial. So that's about 30 to 40% of annual salary of a teacher. Second of all, the rules are very, very clear. The teachers know exactly the rules and how they're going to be ranked. Okay, so there's no ambiguity about how the thing is done. So there was 629 teachers in the experiment, in English 2007, in math 2037. I won't say anything about this for a moment, we don't have time. And about half of them won any type of award. Some won more than one. There is the female teachers that won 3 prizes. 2 of them were first place with 2 different classes. Okay, so she went home with over $15,000, which is nice. Okay. Okay. So the experimental design, I said there was about 100 schools. About 50 of them were elected based on this threshold. How do I do the experiment? It's not random, right? So here is the trick that I've done. I assigned schools to the program based on the average matriculation rate, but not the true one, not the final one. The ministry produced for me an average matriculation rate about 4 months before they usually produce the final rate for every school. It was produced based on very preliminary data. A lot of the students were not featured into the mean that was computed. And there was a big gap between the true rate at the end and the preliminary rate that I got, okay? The difference between them, sometimes were very large, sometimes very small, was totally random, related to idiosyncratic factors related to the school and to the ministry. That assignment variable is measured with error, and the error is random. So you basically use a random number to assign schools to treatment. And that number is totally orthogonal to the true quality of the school and the true matriculation rate. So you see here, that's the correct matriculation rate, and that's the erroneous matriculation rate. If the true and the correct were the same, all the points would have been at the 45-degree line. Okay, they would be the same. But you see that many of them are below, so the true rate is higher, the measured with error rate is lower than the true rate. So take a school that, let me just finish this reasoning. Let's say a secular school, if in the measured with error rate he was 45 or below, he would be included in the program. Suppose a school J was with the error measure at 40%, he was included in the program. The true rate placed him at 55, let's say. He should have not been in the program, but because of the measurement error, he was included in the program. Okay? Take a school who was not in the program because his measured with error rate was 47, but his true rate would have been 40. He should have been in the program. So there are schools who should not have been in the program that were included randomly, and schools who should not have been in the program, who should have been in the program and were not included randomly. So this is random assignment basically, and I show in the paper, in the AR paper, that this is really unrelated to anything about the school, about the student. It's a true error term. So there's also an RD identification to be just above 45, just below 45, that I use for identification, and I show that there is no bunching. Unlike the paper I just described in terms of religiosity, where there is bunching, here there is no bunching at the point of being assigned to the program. And these are the McCrary tests for continuity at the thresholds. So I use also an RD approach. Okay. So the original paper showed that the program have led to improvement in high school outcomes. First of all, in terms of math and English. The test rate, how many students took the exam, increased by about 4 percentage points. All these are significantly different from 0 at 1%. The pass rate, how many passed with 55 or above, have increased in math and somewhat in English. And the test score gain are 5.3 points, which is about 0.25 of a standard deviation in math, and in English, about half of it. Okay? There was also an effect on overall outcomes of the matriculation program. And in particular, you see that the matriculation rate have increased by about 3 percentage points. Okay. Now, when we do intervention in education, we focus on test scores. But who cares about test scores? What do we care about? We care about outcomes in the long run. The well-being of individuals where they are adult, where they are good citizens, where they support democracy, where they are kind to their neighbors, okay? Where their intervention make people be better. We don't care if they get higher test scores, if at the end they don't study more in college and their earnings are not higher. So we really want to focus on long-term outcomes. Because of data limitations, we all focus mainly on short-term outcomes, but we really want to focus on long-term outcomes. So we want to see whether those gains at age 18 of a pay-for-performance program made meaningful changes to the life of students who were treated 15 years earlier. So again, here I use data very much from the same sources I described to you in the previous paper, also using them in the lab, combining data from the Israeli tax authorities, from the Ministry of Education, from the Interior Ministry, because I will look at outcomes that will span from post-secondary education. I want to know whether students who improve their high school outcomes went and studied at a college at a higher rate or in universities at a higher rate, completed at a higher rate academic degrees. I want to see whether they are working more, so they are more employable, and whether their earnings at age 30 to 35 are higher. And I want to look at their personal life, how it affected their marriage, how it affected fertility until that age, and also for those married, the quality of their spouse. Are you marrying up or marrying down when you improve your educational outcome? Okay? So those are interesting outcomes that will determine the quality of life of the individuals as adults that we want to look at. And the data allow us to do all this. So there is, in the original paper, I showed that there is a control group and there is a pre and post cohorts, and the treatment and control on baseline look very much the same. So, but I have to repeat that based on the long-term outcome. So suppose enrollment in post-secondary schooling. Okay, so this is the pre-untreated cohort. Treated schools, non-treated schools. How many of them are enrolled in university? 22%, 19%. The difference is 2.6%, and it's not significantly different from zero. How many are enrolled in academic colleges? Okay, 15%, 14%, the difference is zero. Okay, years of completion of post-secondary schooling. On average, 0.8 of a year, 0.7 of a year, the difference is 0.1, not different from zero. Academic colleges, the same thing. So they look very much the same in terms of long-term outcomes at baseline. Employment and earnings. There is a bit of a difference here in favor of the control group, okay? And this paper is sort of R&R second round at Review of Economic Studies, and the referees give me a lot of hard time about this, and I didn't know why, when everything else looks the same in high school, etc., in earnings, there is a difference, even though it's not significant, but there is a difference. So looking again at the tables again and again and again, and finally I figured it out. I have in the treated group 3 Arab schools, and I have 0 Arab schools in the control group. Female labor force participation of Arab women is 20%, even among the educated. Female labor force participation in the Jewish population is close to 80%. So average earning is lower because many of the women are not working in those students who came from those 3 Arab schools. Also, for a given occupation and outcomes, you will find that Arab employees in Israel get lower wages. Some will argue due to discrimination. So that also explains that. Once you have added dummy to a cross-section balancing regression and accounting for Arab versus Jewish school, this goes to 0, okay? Which is nice.
So
okay.
How long did the intervention last?
Oh, I didn't say that, of course. So this intervention was targeted to 12 grade teachers. They were assembled on December 20th to a conference at the Ministry of Education. The school headmaster and all the math teachers and all the English teachers came from all 50 schools to the meeting. I explained to them the program over 2 days. The program started January 1st. Now, we didn't tell them about it until that date, so they will not be able to manipulate the roster of kids in different classes. So there is no manipulation of, someone asked me before about the attrition in samples. So the samples are before any possibility for school. So it lasted 6 months. So they had 6 months, work hard to improve the outcomes of their students. Okay? And if you look at the original paper, there is evidence or mechanism how they have done that, okay? In terms of effort, in terms of concentration, in terms of focusing on certain groups of students in the distribution of ability. Okay, so let me show you the results. Effect on post-secondary schooling. So first by graph. I observe the outcome for every student for every year since graduation. And since there is before and after, everything is measured in terms of years since graduation. So this is the effect on university enrollment, that I see you studying at least 1 year in a university. The mean is increasing. There's year 0 when you finish high school. Until year 3, it's meaningless because you are for 3 years in the army if you are a man and you are a Jewish man. And you see that increasing gradually the enrollment rate until about 20%. 13 years after high school graduation. The treatment effect is positive from about year 4 or 5, becoming statistically significant. The dark area is the confidence interval. The green is the treatment effect estimates. And you see that after 8 years, basically it's stable. So you reach a plateau and it doesn't increase, okay? You see here the years of schooling effect is increasing continuously, although at a slower pace, because more and more years are completed, but enrollment is already fixed. That's on universities. In Israel, we have 7 universities and about 60 academic colleges that confer academic degrees, but they are of a lower quality, and admission to those colleges is not based on your matriculation diploma. So improvement of the matriculation rate doesn't really affect your likelihood of getting to a college. And you see the effect on colleges is practically 0 in enrollment and 0 in terms of years, okay? And it's not significant. So the program, until age 33, improved enrollment by about 5 percentage points, relative to a mean of about 21% or 20%. That's a non-trivial effect. That's a 25% improvement. And improved years of schooling by about 1/4 of a year of schooling relative to a mean of a 0.8, which is also a meaningful 20+%. Okay? So that's the gain for the treated in terms of being in a school, in a class where your teacher was paid in a rank order tournament, a bonus based on the student's performance. This is the same exercise based on a total different identification. The first one was the measured with error or natural experiment. This is the RD. It's a different sample, and you get almost exactly the same result. Almost exactly. Effect on university enrollment in years, 0 effect on colleges enrollment in years. So these are sort of a point estimate that are done 12 years after high school graduation, and you can see here the point estimate and how precisely they are in the table. Then, and that's for the years of schooling. The effect size is meaningful. I compare it to some results from other studies done in Israel, and I will leave it aside. Now, this is interesting. Do we observe effect on earnings, okay, over age 30 for the original intervention? So this is the effect on earnings, okay? And so this is nice. Why is it nice? Why do we see this dip? Yes?
Because people go to college.
People are in school. So the treatment effect on earnings, here they are in the military. From 0, 1, 2, they are in the military, men, and women are in 0, 1 in the military. Well, you see that there is a dip here in earnings, reflecting the fact that a higher rate of the treated students are in college or in university. We know it's university. And then the payoffs come after the 5th, 6th years, when they start working and earnings is increasing, and you see that it's significantly different from 0. Okay? So, this is the natural experiment sample, this is the RD sample. Two different total identification strategies which yield exactly the same result, not much of an effect on employment.
What happened on year 10 that goes down?
Yeah, you know, I mean, I don't know. Earnings are a weird beast. It has noise in it, and I couldn't figure out. Okay.
Do you know?
Now this is nice. What? I'm sorry?
Do you know whether they have kids or not?
Yes, yes. Yeah, I'll show you results again. This is the results on earnings by gender. Okay, so why is it nice? The green is the girls and the blue is the boys. Now girls serve in the military 2 years and boys 3. So we want to see everything shifted to an earlier period for girls relative to boys. And indeed that's what you see. It starts going down and negative before it goes down for boys, okay? And it starts going up a bit later because they study more years. And then everything is following more or less the same path, although the effect on girls' earnings is lower, okay? So this is sort of a nice rational result in terms of the timing of the effect, given that we have this constraint of 2 or 3 years in the military.
What year was the intervention again?
The intervention was in academic year 2000, 2001.
Okay, I was thinking the year 10 could reflect like the global recession.
Right. It could be because 2008, 2009. But
I don't know.
but why the treatment effect? It diffs and
Right,
diffs.
why did the treatment differ? It's if it like affected people who
If-
are higher educated.
Exactly.
Or not more
If let's say the
affected.
high-tech industry where there are more educated people were hit more,
It could have lowered
that
it.
could explain a dip in the treatment effect. Right. This is sort of interesting, the heterogeneity of treatment effect by socioeconomic background of the students and the gender. Okay? So let's look at the high family income and low family income. When I did the first analysis 10, 15 years ago, I had no data on family income, but that became available to me in these labs. So I added controls for family income. I showed that in the paper it doesn't make of a difference. But here I can divide the sample into high family income and low family income in 2000. Family income in 2000, before the program was rolled. And you see that the effect on high family income on university enrollment and years of schooling is larger than on those from lower family income. But the effect on earnings is much higher for the low family income than the high family income. And that's because there is a large effect on employment on the low family income. Okay? So higher education make the people from low family income more employable, and that translates to a large gain in earnings, much more than we see for those from high family income. The same thing we observe for boys and girls. The effect on girls' education is larger than on boys. But boys have an effect on employment, while girls have no effect on employment. And then you see that the effect on earnings for boys is larger than for girls. Okay? It's not totally precise because the samples are getting small, so that's a sort of suggestive evidence about heterogeneity. But what we see here in terms of inequality, and the topic of this paper, is that pay for performance, which is really a market mechanisms, okay, actually lead to improve income inequality because it increases the earnings of those who come from low-income families more than. And I also run regression in terms of percentile ranking of students in the distribution of individuals in the country or within the sample of the treatment and control. And I saw that mobility, income mobility, is higher for those who, due to the program, higher for those who came from low-income families relative to those who came from high-income families. Okay, that's the RD results, which are very similar. It's interesting to discuss whether the effect on earnings is large or not. and I compare the results given the rate of return to schooling in Israel. And this, yes?
Do you think that teachers might have reacted to those incentives of determinant by reshuffling their resources, in the sense that if I'm teaching in various classes and one happened to be just, with more smarter kids on average before the intervention, then I might focus on those kids and dedicate more resources to them. And also if there's really smart kids in one classroom, I might neglect them more than I would have done otherwise.
Yeah.
So is there something going on?
Yeah. So they did actually. They behaved strategically. I interviewed all the teachers in the summer after the program with a long questionnaire. Because the program, the tournament was designed with a bonus payment if you improve the passing rate, teachers strategically focused on students who were at the threshold of passing. That's for sure. And they said that. But they also had to gain by improving the average test score of the class, which comes from the whole distribution. Now, naturally, if you have students who would score otherwise 90 or 95, potential improvement in their test score is relatively limited because of the ceiling effect. So they focused less on the very good students, more on those in the middle of the distribution, those who are in the area of passing, and those who are between the passing rate and, let's say, a score of 80 or 90. So in the third quartile of the ability distribution as they see it. Okay? But they've done a lot of things. Like in Israel, towards the matriculation, there are sessions that we call marathon sessions, where the teacher meets the students for a weekend. Like they work hard in the school and they stay and sleep in the school, or they go to some retreat somewhere cheap and they stay with the teacher. Marathon activities increased by 70% among treated teachers relative to non-treated teachers. So one of the criticism of the paper, the early paper that I had, was that it's all teaching to the test. My reaction to that, what's wrong with that? If it leads to higher university schooling and higher earnings later on, what's wrong with teaching to the test? So if teaching to the test doesn't leave you with any meaningful human capital, that's something else. But the fact that you get higher post-secondary schooling and higher earnings suggests that it is a meaningful human capital. It means that some students who are bumped up the threshold of getting a matriculation diploma and going to university were basically unutilizing their potential. And you bump them up and they do that. Okay. Well, I have things related to how the outcomes are related to earnings. I won't spend time on it. Effect on marriage and fertility, no effect, practically. So I don't see, at least until age 32, 33, any change in the average age of marriage. I don't see any effect on parenthood, okay? And looking at the quality of the spouse is a bit tricky because it's based on a selection sample, only those who got married. They're not a random sample of those treated. But even based on that selective sample, I don't see much, but then again, that's not identified. Okay? Okay, so I go back to my earlier report about the black box of teachers' quality and the Chetty results. I think that I like the value-added papers. I do it myself, and I think it's very useful. But we must understand what makes a teacher a better teacher. Okay? So I mentioned the paper with Josh Angrist about on-the-job training. That's one mechanism that I fully believe in it. This is one design of a mechanisms that can lead. One should try much more of this type. There are other papers looking at short-term effect of pay-for-performance schemes in India, in the UK, in other countries that show some effectiveness. The studies in the US are not very promising. I think much to do with the design of those experiments, much of them initiated by state policymakers, not giving careful attention to the design and make it really a useful design that will have a potential for improvement. But if you guys are going to work in this area, I think it's very, very promising to work on teachers' quality and try to penetrate into the black box of effectiveness of schools, in particular teachers, and try to disentangle something in that box so policymakers can rely on that to improve schooling outcomes. I don't have time to talk about school choice. Leave it some other time. Thank you.